In this video, we're going to look at another example assembly for the SolidWorks Associate exam. This assembly here you can see is three parts. You have what would be probably a screw down pin, this part that fits over the block, and then you have this block here that has this distinct shape to it, and this would be for holding down up a part in this V shape here, and this would in reality most likely be a screw that would go through, but the drawing doesn't require you to make a screw. I'm going to start off by starting a new part. I want to put a picture of our assembly up here in the corner. You should be able to see this while we're drawing. And what we're going to end up doing is making all three parts, and then we're going to assemble them in the orientation that they're described here. And you can see a few indicators here for what our assembly needs to be as far as the distance that this pin is put down into this holder part, and how far down the block this the holder is located. So we'll start with the first part. We're going to start with the easiest of the parts, and we're going to make this pin. Alright, so if we look at this pin, we can see that most likely it'd probably be pretty easy to just do a revolve for this pin, given that it's a circle or cylindrical. So we'll go to the front plane, we'll right click, we'll go normal to the front plane, and we'll start a new drawing. And from here, we can figure out how we want to orientate this whole thing. So we have a few indicators here, and I think honestly we could start by putting in some reference lines here. So we know we're going to need a vertical reference line to rotate everything around. So we'll draw that in. Escape. And then we can actually just start drawing, because with this in here, and remember we're only going to draw to one side of this reference. So this is pretty simple. Bring the part out, up, step it out, and back in. And then we come down to here. Okay. And push escape. And now what we'll be doing is we'll just be giving our dimensions to this piece. And if we look at the drawing, we can see that the top diameter of this piece is going to be 24. So everything we're dealing with here is essentially radius. So if the top diameter is 24, then this length right here needs to be 12. Pull off of there. 12. We see that the height of this top part of the pin is 20. And we can see that they don't actually show the pin radius, but they show the dimension of the hole that it goes through in the holder, and that's showing as a diameter of 12. And we'll make this 6. And then finally, we need the height distance here. And what we can do, the other thing we can do is let's so that all of this is orientated correctly. We'll take this center point here once we do the height of everything, and we'll drop it down and make it coincident with the origin. So let's see here. Our total height looks like it's 100 off of the drawing. So from here to here, that's 100. Now if we push escape, click on this point here, drop down, push control, click on this point, coincident. Now when we zoom out, you can see that this object is fully defined. Right? Say OK. And then we go feature, revolve boss base. It's automatically going to pick up the line it wants to revolve around, which is that center point line, and we say OK. All right, so now we've got that done there. Looking at the drawing, we can see that we have a hole that goes through that top piece with a diameter of 5. So we can go back to that front plane, and it's 10 down from the top. So we can go to the front plane, go normal to that, and we can start a new sketch. And on that new sketch, we're going to draw a circle in line with the center there. And we'll say OK. Smart dimensions. We'll make this diameter 5. And then we will go smart dimensions, and from this top point down to here, that's going to be 10. Click on this point here, click on this point here, and we can say vertical as well. There we go, now we're fully defined. So even though when we were drawing it, it drew that reference line down and we snapped to that reference line, because we didn't have a reference line actually on that drawing to associate it with the origin, it was guided to that point, but it wasn't actually locked into that point as part of a join or a mate. So this gets us locked into that point. And so now what we can do is we can say OK, and we go to feature, and we can do extruded cut, and we can select, I would say, up to surface. We should be able to, since this is cylindrical, and we should be able to say in both directions. And this one will say up to surface. And then we can say OK. We have we need to pick that surface a second time. All right, and then we can say OK. And there we go. Now that hole is drawn through. So this is our first part. All right, the final step we want to do with this is we want to put our material on here. And so our material is going to be 1060 alloy. This is an aluminum alloy. We right click on our materials, we go edit material. We go to our 1060 alloys, our aluminum alloys. I already had this open. Our 1060 alloy, and we check that our mass density is correct. We have 2,700 kilograms per meter cubed, and that converts correctly to the 0.0027 grams per millimeter cube that our material requests. So we say apply, and we say close. And now this is the correct alloy. And so that's pretty quick. There's our first part done. We can save this, and we'll just save it into a folder that I have set up for assemblies here. We'll just call it pin. Okay. So now we want to go and we'll do a new part. All right, so let's draw our yoke. And so we're going to start on our front plane. I'm going to choose a new sketch. Let's draw in our center point line. Make sure it crosses through the origin. We'll drop down. We'll say OK. All right, and so we're going to start off. I'm going to start off by drawing the inner arc on this. It seems like kind of a weird place to start, but I think it will actually work out all right. And if you look at the drawing, you kind of see that a few things kind of rotate around this point. So let's actually just start that point up as the origin. And what I'm going to do is I'm going to actually start it as a 3-point arc, because what I'm going to do is I'm going to draw one side of this, and then we're going to mirror that side over to this side, so that we don't have to draw both sides. So we're going to go here. We're going to go 3-point arc. I'm going to pick our origin as my first point. I'm going to go up off the line, and then I'm going to come down, and you can see in the drawing that this is a quarter of an arc, or a quarter of a circle in the drawing. All right, and then we can push escape. All right, so we've got that first arc drawn right there. And now we can go in and we can get our line tool. And from here, we're going to go out, and we're going to drop down. You kind of want to keep this, keep an eye on what the drawing looks like so you can keep your proportions relatively close. And then this piece is going to come back in. It's going to come back in so it's vertical with that point. And then we'll drop down again a little bit. We'll come out. We'll come up. And we're actually going to come up to that point. So we're in line with that point again. We're going to come away, come back to it. We want to come back to it that way. So we have a little bit of an arc here. You can see on the drawing it's calling for a radius above 4 on that arc. We'll come back to this point. We'll draw up to somewhere roughly here. Stop that arc. Come back to it. Draw another little small radius arc. We're going to go up vertical. And then we're going to come across horizontal. And click on that line. And then we can push escape. So that's roughly the start of our drawing. First thing we can do is we know that the center point for these two arcs are off of the same point. So we're going to take this point here, we're going to click on it, and we're going to push Control, and we're going to select the origin. And then we're going to go over here, and we're going to make that coincident. So that's going to squish some things a little bit, but we can fix that right now. So we'll say OK, and we can go over here, and we can drag some of these pieces away a little bit. All right, so doesn't look perfect yet, but let's get to it. All right, so we know this inside arc is going to be 24. So if we go to Smart Dimensions, we can grab this inside piece here. We'll click on that. And we'll say 24. And that gives us a good reference start. And we see the outside radius is going to be 36. So that's going to stretch everything, kind of put it into close to the right proportions, but we can see some stuff adjusted there, but that's fine, right? We know that this line down here is going to be 16. And we can see that it's stepped in based on what the drawing looks like by 6. So we know that our distance from this edge to this line now is going to be 10. So if we go here to here, we know that this is supposed to be 10. And that should kind of reverse things back around a little bit and start making things look a little bit closer to reality. We know that this height right here is 36. So that shifted that a little bit. And we can see a few other dimensions here. So some of the stuff that we want to look at is not only on the yoke in the drawing, but also on the block, because the base block has some dimensions on it as well. So we can see that the distance from this line to this line is going to be 24. And that dimension is on the block. So if we do that, that drops us down a little bit. And then we can start giving our dimensions to these radii too. So we can say this is going to be 4. And this is going to be 4. We have our dimension here is 24 across the top, so that we know that this is 12. Right? And we know that our height, total height for this block is going to be 80. So from here to here is going to be 80. All right, so that starts to shrink things down a little bit. And we can see in here that the gap on the block is the total height of the block is 60 by 60 is the face of the block. And so this height here is 24, and the bottom height would be 24. So if we add those together, that's 48. And so that we know that the distance here is going to be 12, because this has to fit into that slot. All right, and when we do that, that actually brings us all up, and we're fully defined across that face. So that's the entirety of this piece. So now what we can do, there's 2 ways to do this. And actually one of the ways that's a little bit simpler, because you can just select the shape, is we'll say OK. We'll go in here and we'll draw another line real quick. And so we'll connect these 2 pieces together. And when we do that, it gives us this shape. We can say OK. And then what we can do is we can select this shape and we can say mirror entity. And we'll want to mirror this entity. We want to mirror it about this line. And when we do that, you can see that it draws it over there. And we say OK. So now that's drawn over there, but it's drawn as two shapes. Now, to get rid of that line that we just drew there to make that a solid shape, we just go trim entity, and now we just have a single shape. We can say OK. All right, so now we have our single shape, fully defined, fully drawn. We need to extrude it out. So we go to Features, and we go Extruded Boss Base. And you can see on here that this shape is going to have a center hole up here in it that is going to have our circle in it, or our hole that goes through it. And so an easy way to do that is we see that the depth of this yoke is 20. So let's extrude it in two different directions. So instead of going one direction off of there and then having to measure out for our circle, we can actually go in two directions, 10 in each direction. That gives us a total width of 20. And we can say OK. And when we do that, we can then go and we can select this face here and we can do New Sketch. And when we do our new sketch, the origin then is at the center of our object as far as looking down at it vertically. So then when we go here and we draw a circle, that circle is now centered through the origin and centered onto our piece. We say OK. We go Smart Dimensions. We look at this and we see that our diameter on this needs to be 12. Grab that, pull off of here, and we will say 12. All right, and that makes that circle fully defined. And then we can go to Features, and we can say Extruded Cut. And let's do up to surface. So just in case this surface was to change at any point in time, we can say up to surface, spin around here, pick that surface, and say OK. And like that, our piece is created. Now the final thing we want to do is we can see over here in the directions that they say that our components are all supposed to be 1060 alloy components, which is an aluminum alloy. And we want the density to be 0.0027 grams per millimeter cubed. So if we go over here and we right click on our materials and we say edit material, starts off steel is drop down. We'll close that up and we can go to our aluminum alloys and we can click on this first 1060 alloy. If we look down here, we can actually see our mass density is 2,700 kilograms per meter cubed, and that converts to our 0.0027 grams per millimeter cubed. So we can say apply, and we say close. And so now our piece is complete, and we will save our piece, and we'll go on to the next piece. All right, so the next part we're going to draw is the base of this, or the block. So it looks like we could probably just draw this as a quarter of the drawing and just mirror it around. So let's go to our front plane, right click, and we'll do a new sketch. And let's draw in some reference lines here. All right, we want our reference lines to pass through the origin. Alrighty, so now we can go and we can start our sketch. And let's start our sketch up here. And we'll bring this out a little bit, come up at an angle, over horizontal, down. And we can see here that the distance from the top of the piece to the center of the groove is 20, but the distance from the top of the piece to the bottom of this next slot is 24. So we'll drop that down a little bit because we don't want those lines to be connected to each other. And then we can just drop down to here. If we push escape, that gives us essentially 1/4 of what our block is going to look like. Now let's start giving it some dimensions, all right? And like I said, I don't know if drawing this as a quarter will be any quicker than if we wanted to draw this piece as 1/2 or as a full piece and define that way. But let's give it a try like this. I'm going to put in a reference line here because we need to be able to reference our angle here. So we'll draw in a horizontal reference line there. Call that good. Okay. If we're looking at this, we can see that we've got a few dimensions here that we can use for this. So we have our overall width and height of our block is 60 by 60. So we know from this edge to this center point it's going to be 30. So we go in here and we say smart dimensions, let's make this 30. And that will give us a good starting point. And then we can go here and we can click on this line here and this line down here. And we can tell it that that's 32. All right, so we scrunch a few things in here and we're starting off all right. We can go here and say, here we can say this is 24. And we can go here and we can say distance from here to this line here is going to be 20. Okay. Now, all we have to do is a few quick corrections here. So we know that this angle from here to here is going to be 50. All right. And if we look at our drawing, we can see that we have a few other things here. So the width, the total width of the, from the points of the slots to the other point of the slot on the drawing is 40. And our total width is 60, but we can just go from this point to the center line, and we can say this is going to be 20. All right, so that's fully defined all of that. And then if we look down here, we know that this is 24, but this is 30. The only thing that's not defined is the depth of this cut right here. And so we'll have to look at this and see if we can figure out what the depth of that cut will be. And it looks like the depth of that cut is 6 if you look at the left-hand side of the drawing. So this value here is, oh, had another line connected. This value here is going to be 6. And that should give us a fully defined drawing. So now, if we select those entities, we don't need, we can push control, we don't need the dimensions on there, so we just need the lines. So now we've got this all selected. Now we can go here and we can mirror entities, and let's mirror about this line here. So that mirrors us there. We say OK. And then we can do the same thing here. We can do the same thing here. And we'll push control and we'll turn off these dimension lines. Once again, probably doesn't matter too much. And we can mirror these entities. We're going to mirror them about this line here. And we say OK. All right. And there is our fully defined block. Was that any quicker than drawing 1/2 or the whole thing? Might have been. I don't know. It's a few less dimensions that you're putting in. A few, like you don't have to do all of the relationships between the lines if you're going to make stuff equal and things like that. So it still was relatively quick. Now we can go to features and we can extrude boss base. And let's extrude this. Doesn't really matter which direction we extrude it. It's 100, but let's extrude it backwards off of this. So we'll go off that back side and make this piece 100. There we go. And there we go. And that is the base piece for our assembly. All right, so the final step on this one is to assign our material. So like all the rest of them, we want this one to be a 1060 alloy. So we right click, edit material, choose our 1060 alloy, apply, close. So with that done, we can save this, and we'll save this as the base and say OK. So now we can go up here and we can say new, and we can say new assembly. And we want to bring in our parts. And what we can do is we can look at the drawing. And if you look at the drawing, in the bottom right corner, we have our X, Y, and Z origin. And that origin is coinciding with the bottom corner of that block. And that can make some of the center of mass is going to be referenced to that origin. So what we want to do is we want to bring in that block and we want to put it into that position. So we're going to bring in our block first. We'll bring this in. We'll push escape. And we can look here, and this probably brought in and locked in our origins into the same place. What we want to do is we want to click on this, and we'll want to make it so it can float. Because right now it comes in and it comes in as a fixed position. And now we can click on our origin, which is over here. You see that over there. And then we can push Control, and we can click on this point there. A point. Okay, and then we can make them coincident. All right, so that brings us over to there. And then the other thing that you can see is that this is going to be, if we show, we have our Z, our X, and our Y, and this is our negative X and our negative Y going down there, and you look at the drawing there. And so if we look at our planes here, let's lock this face. So not only is this at the origin, but let's lock this face onto that front plane. So we can say front plane, and we can push Control, and we can choose that face there. And then let's make those coincident. All right, so now this piece is locked at that corner and that face. So even though it's still technically floating, we could turn it to a fixed position. It doesn't really matter. It can't really move because it's locked into that position. Actually, it could, because it could rotate around that. So let's just right click at this point in time and say fix. So now it's locked into this position. Okay. So from there, let's bring in our yoke and our pin. We can add, we can go to our assembly, we can insert components. We're going to bring in the pin, and we're going to bring in the yoke. All right. So these two pieces go together. We can click here and push Control and click here, and we can say this is going to be concentric. And then if we look at the drawing, or if we read the reference material in here, it tells you that from the top of this pin to the bottom of this plate is going to be 60. They actually tell you that adjusting the pin in this piece is going to be 40. The other thing you want to look at here, and we can adjust the face of this pin because it's interesting. It runs perpendicular to this piece here. So we might want to adjust those as well so that they're adjusted to each other. But what we'll do is we'll do that once it's up on this block. Let's go here, and we can click on this face here. And we can come down here, push Control, click on this face here. And we want to say that the distance here is 40. All right, so now those two pieces are locked together. We push Enter. All right, now what we want to do is we want to add the yoke to the block. We'll do that with two mates. The first mate we'll use is this face and this face. We will make those a coincident. And then we can go here and we can pick this face here and push Control and that face there, coincident. And then we'll take this and we'll slide it back, and we see on the drawing that this yoke is slid back from this face 60. So we'll do another distance made here. So click on that face, this face, go distance, and we say 60. All right, so finally what we want to do here is we want to make the hole up on here in the pin, we want to make that hole perpendicular to the block. So the way we're going to do that is we're going to pick two features, and we're going to pick the inside bore of that hole, and we push Control, and then we're going to pick this line here, and we're just going to choose perpendicular, and that will spin the bore around so it's running perpendicular to the hole. So once we've done that, the final step that we want to do is we want to look and we want to see what our mass properties are for this object. So if we go up here and we click on mass properties, we can come down here and we can see what our center of mass is. And if you remember in the question, I'm going to pull that over here so we can see the question. It's asking what the center of mass is, and it has a multiple choice here. And you can see that these values here for our center of mass off of this origin are coinciding with the selection of the letter D. So this would be the selection you'd pick. And it's kind of nice that this is multiple choice because it allows us to kind of cross-reference what we'd be looking at here. So this is our final object, and if you have any questions, feel free to reach out to me and ask.